Okay, so before we get into ordering fractions, we should first get an idea as to what an equivalent fraction is, which means that fractions that are exactly the same in size. So what we've discovered so far is that if we have one object here, we can say that we have one whole object, and as a fraction, this can be represented as 1 over 1. There's one whole piece and it's only split into one section, so it's represented as one whole. Now if we were to take this object and say we split it in half, well, now this object is currently being represented by 2 over 2. So what we can say then is that the object itself hasn't actually changed, it's just that the number of parts right down here that we have cut it into has. So, but the overall size of it hasn't changed. So we can say that 2 over 2 is the exact same, or it's equal to 1 over 1. So both of them represent the whole object. All right. Well, let's take a look at other fractions here while we're at it. And let's say we were to split this into, we were to shade in 1/2. Now, as you can see, we have shaded in 1/2. So this can be represented by the fraction 1 part out of 2 parts, or 1/2. Well, what would happen if we were to actually divide this up again and say, okay, well now we have 4 parts. So this entire thing, if we had all of the entire thing to have one whole, would be represented as 4 out of 4 parts. And out of this, we can say that 2 of those parts, 2 of those parts are shaded. 2 out of 4. Well, now if we start to actually think about it, if we haven't actually changed the overall size or shape of this entire unit, this entire object hasn't changed at all. All we've done is cut it into smaller parts. So what we can say is that 1/2 is the same as saying, or equal to, 2 out of 4, 2/4. All right, well, let's see if we can actually break this thing down a little bit more. What if I were to do this? Well, now what I've done is I've created a situation where that exact same shape has been broken into 8 parts. 1, 2, 3, 4, 5, 6, 7, 8. So we can say it's now 8 parts, but I haven't shaded anything more in. We have the exact same amount of space that is currently shaded in. None of that has changed, but the number of parts that have shading in it has. We have 1, 2, 3, 4 parts that are shaded. Even though I've done no more shading, all of these fractions are actually equivalent because they still cover half of the overall size of this object. So 1/2 is said to be equal to, or an equivalent of, 2/4, and 2/4 is equal to, or an equivalent of, 4/8. The same as 4/8 is equal to, or equivalent to, 1/2. All right, let's take a look at another example. We have an object here that is split into 3 parts. And if we have all 3 parts, it is equal to 3 over 3, or 3/3, which is also equal to 1 whole. And so when we have all 3 of those parts shaded, it would be 1 whole. But let's start off by shading this part right here. So as we can see now, we have a fraction of approximately, well, exactly 1 out of the 3 parts that are shaded, or 1/3. Well, what would happen if I split this again? Well, I haven't changed the shading in it at all, but I have changed the number of parts that are in it. I now have 6 parts. So I can say that I now have 6 parts, and of those 6 parts, I have 2 that are shaded. What if I was to do it again? What if I was to split this up again? What if I was to do this? Well, now what I've got is I've got 1, 2, 3, 4. I've got 12 parts, and of those 12 parts, I got 1, 2, 3, 4 of them shaded. So I can say that 1/3 is the exact same size as 2/6, and that 1/3 is the exact same size as 4/12, and that 4/12 is the exact same size as 2/6. But one of the things that causes a lot of confusion is that when students see these big numbers on the bottom, we automatically assume that those numbers are larger. And in fact, that is not the case. What it means is that the parts are actually getting smaller. So this is an area of confusion that we will be covering when it comes to ordering fractions.